All right. From college algebra or pre-calculus, if you had a log base a of x, we had something called the change base formula that allowed us to change it into whatever base we wanted, but usually we wanted to change it into base 10 or base e, which is the ln, because that's what most calculators have buttons for. Um, in this particular textbook in calculus, we have a different build, and we define log base a of x as the ln of x over the ln a. So it's our change of base formula, and this allows us to easily find the derivative. So the derivative of log base a of x is just the derivative of ln x over ln a, and ln a is just a constant, so it's just going to hang out when we take the derivative. The derivative of the ln x is going to be 1 over x. So what's going to be upstairs is just 1. Downstairs, the x and the ln of a are going to hang out. Okay. And of course, if we have some differentiable function u of x, we can use the chain rule. So you'll have the derivative of the argument upstairs, and then downstairs you will have u times ln of a. So we'll do a couple examples of taking derivatives of logs that are not base e. Let's see, y equals log base 2 of cube root of 2x plus 1. Remember, logs are just like natural logs. They obey all the rules. So what we're going to do is we're going to use the power rule for logarithms. This is different than the power rule for derivatives. Cube root is the same thing as the 1/3 power, so we're going to go ahead and put that 1/3 power in front. So 1/3 log base 2 of 2x plus 1. Now we're ready to go with the derivative. 1/3 is hanging out in front, times the derivative, so we have a composite, so derivative of the 2x plus 1 is just 2, and then it's going to be u times ln of the base. The u is the 2x plus 1, and the base is 2, so ln of 2. And if you want to rewrite that a little bit, we can just make it look a little nicer. You can distribute that 3 through if you want to, but I'm just going to leave it as is. Okay. And all right, let's try another one, something a little bit more crazy. So k of x is equal to ln, oh sorry, not ln, log base 5 of 4 divided by x cubed, and the 1 minus x squared and the square root on downstairs. Okay, so we're going to expand this out as much as possible. So remember, if it's in the top, it's going to be positive, in the bottom, it's going to be negative. So it's going to be log base 5 of 4 minus, and then what I'm going to go ahead and do is, I'm being efficient here, is we're going to have log base 5 of x cubed, but we'll bring the 3 in front using the power rule. So log base 5 of x, and then because it's in the denominator, it's going to have a minus, and square root is the same thing as 1/2 exponent. Bring that in front. Okay, and this is a lot more derivative friendly than what it was before, because we'd have all kinds of craziness going on if I was going to take the derivative of it originally. We'd have to use the quotient rule and the chain rule, and it'd just be a giant mess. It still may look a little messy, but this is much more pleasant. And when we take the derivative, the nice thing is log base 5 of 4, that's just a number. It's constant, so its derivative is 0. Okay, so when we take the derivative, the minus 3 log base 5 of x, the minus 3 is just hanging out. And then it's going to be x and then ln of the base. Minus, and then here's our u, 1 minus x squared, so the derivative of that is going to be minus 2x divided by the u, which is 1 minus x squared times ln of 5. And in the excitement of this, we forgot the 1/2, so there should be a 2 there, and those 2's will go ahead and cancel each other out. Okay? So there we are, taking derivatives of logs base other than e It's pretty straightforward. Just need to know your chain rule. I am using the product, the quotient, and the power rule for logarithms. And if you're not real familiar with those, there are some review videos in my playlist. I think it's in Unit 4. There's a playlist called Unit 4, and you would be looking for a video called something like Expanding Logs or something like that. There's also a complementary video in Condensing Logs too, and it's just practicing expanding and condensing logarithms using the product, the quotient, and the power rule for logarithms. And it makes this calculus stuff a lot easier. Just looking at something like this is just going to be hideous to do just as it is. Okay.